Hello there, class. Hey, this is Mr. Rising, and today we're going to talk about basic geometric terms. First thing we need to really discuss in this whole thing is what we can't define. And we're going to dive into that. These are points, lines, and planes. So at any time you need to pause this video to write things down, that's fine. If I'm speaking too slowly, just go for it. Speed it up. Do whatever you need to do. You have your vocabulary list already, so as you come across these terms, you can fill in examples. You can put the definition if you see it, and of course the definitions and examples are in the back of the book. Let's get started with points. Right? We all point at things. Of course, you know what it means to point, but in geometry, a point is a location that has no size, no dimensions. It's not even in the first dimension. It's just an undefined term. As far as a picture goes, we think of a point as a little dot, or sometimes it's used as an X. And again, the point would be right where the two lines come together that form the X. Let's switch over here, grab a pen. You guys like red pen, I'm sure. When we name a point, we always use a capital letter. So for example, this could be point X. A point could be referred to as point P or A or any other letter as well. A line, a straight path that has no thickness and goes on forever. Now line is in one dimension. It could be in length, it could be width, it could be height. Time is considered a dimension. So any 2 points make one line. And pictures look like the following. You'll see this little line symbol. Again, it's got arrows on both ends. Right, so that's a line. It will definitely refer to it by the points through which it goes. So like point X, point Y. So this could be line XY with a little symbol above here. Or it sometimes is a lowercase cursive letter. So like this could be considered line M. Or you could have a line named L or whatnot. Finally, the last undefined term is a plane, a flat surface that has no thickness and extends forever in two directions. 2 dimensions, length and width, length and height, etc. Any 3 points make one plane. So from a picture point of view, you'll see a capital letter, but it's what's called in a script. So it's sort of italic or fancy looking font. Or as far as a drawing, you'd say this is a plane, right? And you have this little symbol. So you could say, you know, the plane made from. So when you name a plane, a capital script letter or 3 points not in a line. Okay? Everyday symbol. Think about a piece of paper. So when you're talking about a plane, again, it looks something like that. And then you could say plane ABC. A, B, and C. Beautiful handwriting, I know. So this is what it looks like in your book. This is a really nice organized way of showing it. So please get this in there into your notes. Of course, these terms I think are also on your definition sheet. You're going to need to know them the rest of your geometric years and probably the rest of your geometric lives. All right, let's do a little example here. Give 2 other names for line PQ and for plane R. Well, another name for line PQ, let me find out. Here's P, here's Q. Another name for line PQ would be that little line N. Okay, I'm trying to write with a mouse, so bear with me. This will get better throughout the year. So that's another name for line PQ. Another name for plane R. Oh, I've got this big plane here. Well, what I need to do is find 3 points in the plane that are not in a line. So T, P, and S are all on a line. I'm not going to use those. So I could say plane. Oh, that's horrific. How am I going to do this? You guys will have to help me come up with a better way to write on my board. Plane. How about V, S, T? right? That's another plane. Two other terms that you need to know and become familiar with here. So we're going to do this here. Here we go. We'll get out a little highlighter. Collinear. Co means together. Linear means line-like, together on the same line. So which points are collinear? Of course, points M, A, and D are collinear. The other term then is coplanar, together on the same plane. So I can't tell if A and D fall into this plane, but these 3 points, B, C, and F, do. Now, just keep this in mind. If you said, name another plane, any 3 points make a plane. So maybe A, F, and D are in a plane, but they might not be the same plane as B, C, and F. All right, what I would like you to do right now is I want you to try this problem. Pause the video, try it yourself, and then see how well you do. Name 3 points that are collinear. Name 4 points that are coplanar. Go ahead, pause the video now and try the problem. All right, let's check your answers. Name 3 points that are collinear. 3 points could be point S, P, and T. Those would be 3 collinear points. 4 points that are coplanar. V, S, P, T. That could work. I could say Q, S, P, T. That would also work. So yeah, 2 different ideas there. Very good. Now, terms that you may already know, we're going to call defined terms. So we can use words we already know, such as point, line, and plane, to define defined terms. So in your book, you've got these terms. Segment, again, a piece of a line consisting of all the points between 2 points. So when we would say here, like the 2 endpoints are A and B, or B and A, and you'll notice the little segment. There's no arrows on this. And so the diagram would be segment AB. You might want to get these right into your notes right now, into the definition section. So again, a segment or a line segment is the part of the line consisting of the 2 points and all the points in between. An endpoint is a point at one end of a segment, or the starting point of a ray. And again, we denote points with capital letters, C and D. So then this is a segment. A ray is a part of a line that starts at an endpoint, such as endpoint R, and extends forever in one direction, whoosh, through S. You guys probably like yellow. I bet you guys like yellow. So it goes from R through S and all points beyond. And RS is the same description, but it goes in a different direction. And finally here, I think my picture is going to get in the way. Let's see if I can just get my face out of the way. That's better. Opposite rays are 2 rays that have a common endpoint and form a line. So point E is the endpoint. One ray goes EF, like this. And the other ray goes EG, like that. All right, I'm going to do some example problems. If you want to try them before I show you how to do it, that's a great idea. Draw and label each of the following: a segment with endpoints M and N. They're already done. Now you might want to try this problem after I say it. Opposite rays with a common endpoint T. Go ahead, pause, try it yourself. All right, so common endpoint T. Well, I should use a better tool. I'm going to switch tools here. You guys wait till you see this magic. I go like this, whoo! And then I go here and I go, whoo! Look at that. And we better put some points on here. Somebody said, oh, I like point X. Somebody said, I like point U. Okay, opposite rays with the same endpoint. Draw and label a ray with endpoint M that contains M. Go ahead, pause, try this yourself. All right, let's see what you came up with. Endpoint M. I'm gonna use my magic tools. What the heck? Look at that. And again, this is endpoint M and it contains n. See, even after just a few slides, I can write better. Cruising on. Okay, so one of the sections in your book is postulates and theorems. So these are things that you are going to have to go back to time and time again. This is a great place to use those definitions. We'll probably end up putting all those definitions and theorems in one section of your book. So a postulate or axiom is a statement that is accepted as true without proof. So you can't prove it, but we're going to call it, for the sake of language, as a truth. So postulates about points, lines, and planes help describe geometric properties. A postulate about me: I am not a Martian. Try proving it. Try proving I am. Try proving I'm not. Good luck. We're just going to accept it as truth that I am not a Martian. I'm a Pennsylvanian or a Pittsburgher. Okay, so here is your first set of postulates. These are fundamental properties of geometry that we all accept as truth without proof. These should go in the theorem section of your binder. I would like you to get those in there right now. The first one that we're going to talk about is through any 2 points, there's exactly one line. The second, through any 3 non-collinear, meaning 3 points not in a line, there is exactly one plane. And the third one, if 2 points lie in a plane, then the line containing those points lies in the plane. So again, if 2 points lie in a plane, and of course through any 2 points there's one line, then the line containing those points is also in that plane. And we'll show you examples here in just a second of lines that pass through a plane that do not lie in a plane. Okay? Last new word we're going to talk about today is intersection. If they have one or more points in common, they intersect. Okay? So 2 lines intersect in a point right there. 2 planes intersect in a line, and I'll show you a picture of that over here. Let me move my face again. There we go. Okay, so these are the postulates. If 2 lines intersect, then they intersect in exactly one point. If they intersect, it doesn't mean if they're on top of one another. If here's a line, and then you make another one, right? That means they're the same. No, what we're talking about, if 2 lines that are not the same intersect, then they intersect in exactly one point. If 2 planes intersect, then they intersect in exactly one line. So here is plane S, and this yellow one is plane T. And if these planes intersect, then they intersect in exactly one line. And again, a line goes on forever, right? One dimension. It goes on forever. So that is a line of intersection. So a little trick when you're making these drawings, so you might not have realized that this is as much an art class as it is a math class, but when you draw hidden parts of figures, you use a dashed line. Whew! You guys are going to have to bear with me. I can do this much better by hand without trying to do it with a mouse. Okay, so let me just go back here a second. You can see right on this example here, this plane, of course, extends below this plane, and they use a little dashed line right here and a little dashed line right there. Okay, sketch 2 lines intersecting in exactly one point. Go ahead, pause the video, try it yourself. Very good, nice job. So again, I'm going to use a line here. Let me just do this one. Whew, there's a line. There's another line. Of course, they intersect right here at that point. Sketch a figure that shows a line that lies in a plane. Okay, well, let me just start with a plane. And then if I'm going to have a line in it, I'm going to have a couple of, let me change colors. We'll get some red in there. There's a point. There's a point. And we'll make a line through it. I should have used my, let me go back. Wait a minute, I can go back. I can be taught. You guys, you know that, right? I can go like that, right? So this line is now in this plane.